So, ready, set? So, been at this for 30 years now, and I'll say professional boat builder, Ibex, Carl Kramer have been the constants all those times, and it's made a huge difference for our company, And so I'll talk a little bit about this 30-year adventure. I've kind of put this thing into 3 buckets as to what I felt like happened in each decade on this path to making lightweight structures and low cost. So when I started in the 90s, we were taking wood out of boats. The wood that would rot, wooden stringers, plywood, it was heavy, boat hulls were thick. In the 2000s, we started pushing this idea of single skin. Can we take cores out and replace it with lower cost, lighter weight materials? And then now today, what we're doing is we're moving into these new low-cost resins and coatings. And so if you're going to be low cost, look at the price of your materials, and right there are some of your limitations. So to the extent you can, if you can stay up here at materials that are going to be like $2 a pound, you're doing really good, because our real benchmark is aluminum, and aluminum's $2 a pound, and that's where we want to get. In order to do that, the materials we've been using aren't good enough, so we have to make them better. And if we could use it smarter and better, we can make boats lighter and lower cost. So the big gaps right now are brittle gel coats and brittle resins. So the elongation of these materials, the low-cost materials, not the great Gujan stuff, but the polyesters, limits us. So in the 2000s, you'll see here's a C-Ray 26 we did. Back in 1995, we took 50% of the hull weight out from the wooden boat. Big fat stringers, thin hull laminate. We put a V6 engine instead of a V8, 2-axle trailer instead of a 3-axle trailer. At METS in 2006, thanks to Carl Kramer, I presented this innovations in single skin construction. And we were going after some of these areas on boats, low-hanging fruit, where we could drop cores and throw ribs in there and make it a lot lighter and a lot less expensive. And when we did that, we introduced this idea, this is 2005, the single skin transom. And we said, why do transoms have to be built the way they are? Why do they have to be built with plywood? Why do they have to be built with core at all? How about framing a transom? And we did all this analysis, and everybody thought we were just completely freaking insane. Nobody wanted to do it, literally. Nobody wanted to do it. So, like the other guys, we got Navy money, and we used the Navy money to prove this out. And so now you're going to see some of what's coming up here. Now what we did is we've got these designs, single skin transom, and you'll notice the low section framing. And what we do on these boats is we hang the deck on the gunnels, so the whole deck isn't connected to the bottom. And so these boats absorb shock energy. Okay, so by decoupling the hull deck to the bottom, we drive the designers nuts because the rigid body assumption is out the window. Okay, and they're vibrating at their own frequencies. There's a lot of interesting things, but what the low section framing allows us to do is skinny that laminate down to 2 layers of 3610 fabric at about $1.20 a pound. So one of the problems with making an energy absorbing shock mitigating boat is the gel coat can't take it. And when I started, I was looking at polyurethanes, and I found their failing points. And so I got very fortunate and made this discovery that I can combine polyester and polyurethane and create a new chemistry, and it's called CoCure. Well, the Navy makes 300 boats, and it's hard to get a company to develop a product. So I got fortunate that Wabash National got interested in our technology. Then the supply chain, Interplastic, BASF, all these guys invested millions of dollars taking CoCure and turning it into a product. That investment was very, very important. And this shows you a little bit about what's happening with CoCure, where we combine our rigid polyesters, we take chain extension with urethanes, and CoCure is a combination of that. As we put the elastomeric urethane in there, we increase the elongation of the resin. And by we, I mean we, as the builder. So now we can formulate the resin properties and the coating properties right at the gun head. So with 4 chemicals, gel coat, catalyst, A side and B side, I can make this kind of a curve in elongation. CoCure 0, standard gel coat. CoCure 15, kind of a sweet spot in cost, 3% elongation. I can dial that up. CoCure 25 had 35% elongation. Well, what does that do for us? Well, boats are designed around gel coat. Okay, we can do all the calcs and everything, but the gel coat's going to crack way before the boat breaks. And at that point, the customer goes, my boat broke. And so this illustrates what happens where gel coat cracks and laminate failure. If I can prevent that gel coat from cracking, my properties are about 50% higher, my usable properties. And that's on our pathway to lightweight. So just like gel coats, there's co-cure resins. Okay, and you'll see this is the strength increase of a co-cure resin with various levels of urethane. And here's the change in modulus with it. The end result, slides go quick. This is our completed project, not the one you're going to see. But when we started this project with the Navy, had a single engine, inboard Merck Cummins diesel, 35 knots, 5,600 pounds, 3,500 pounds, twin VRP multi-fuel engines, shock mitigating deck, coatings that weather twice as long. So I call this technology stair-stepping, using the government's money to do that risky research, bringing in the commercial market, getting the supply chain to make the investments, and I'm happy to say that CoCure's here at IBEX. It's being released at IBEX. So at the show, CoCure's gel coat is now a product. So for today, I mean, some people just want to get rid of gel coat cracking, but we're looking way beyond that. Because now that we can take this much weight out of the boat because the coating isn't limiting, we're talking about reductions in horsepower, you know, on a recreational boat of about 30%. What's that going to do for our cost? Well, it's about $1,000 a horsepower. Okay. So some other things that are resulting from this. We talked about the resins. There's also two technologies that are really cool. Not here yet in boating, but coming, is we made a discovery that CoCure loves to stick to metal. And we can spray the CoCure on metal, and then we can laminate right on the metal. And so you can make metal hybrids really easily. All right? So I call this the end of the beginning. What can lightweighting do? It can reduce costs. It can reduce the purchase price. That can translate to the tow vehicle and the operational costs. I agree with the other guys. Boats are way too expensive. And if we're going to get the boating public, guys like us, back into boating, we got to make boats a lot more affordable.